Right, so welcome to part 2 of this repair. So I've had it in the sink, and I've got the paintbrush in here with like soap and water, and just to really make sure there's nothing in the slot. Yeah. So let's see if we can put this to bed. Yeah. We'll just get the graphics card, the one we know is good. I'm not quite sure now which of the sticks of RAM was the good one that we were certain of. I mean, I do have a compatible, well, another board very much like this one actually. So there's no problem if we want to test the RAM and the graphics cards in that one. Yeah. So we'll try this first. So we'll get our CPU that way round. Yeah. This is the spare one anyway, but it didn't behave any different to the original one. Can just stick our heatsink on here, yeah, a little bit of thermal paste. Yeah. And let's see what it does. I suspect it probably won't make any difference, but we can try. But so far my luck's been out with the easy fixes on this one, yeah. So we'll stick this on here. Okay, so we're good to go basically. We've got everything connected up. Yeah. Post analyzer cards in there. You can see it's on the camera. Monitors attached. Power leads. Yeah, that'd be good. Yeah. Power leads would be good. Okay, I'll start one in on the 12 volts. Just get the thing to reach over here. Okay. So yeah, we have everything ready to go. Power on, and without any messing about, let's just start it. Well, sticking it in the sink didn't do it any harm, yeah, by the looks of it. We're going to go into this 2B, 2D loop like it did before. Yeah, 2D, stopped. Okay. And then shut down, okay. So that's basically what it was doing before. Yeah. So we know, what do we know from the saw the first video? 2B code means it's effectively passing control to the ROM on here, and 2D means it's returning control, and then it sort of goes click and crashes. Put a PCI graphics card in, we get a picture for a second or so, and then it crashes. Yeah. So it's looking like the problem with this is a communication with a PCIe slot, yeah. And basically on these, that comes via this chip, this PCH under here. If we get under the microscope, you'll see where all these traces actually go into, yeah. I've just noticed, by the way, I was just going to go under the microscope, I forgot to put the CMOS battery on. Again, I don't think that for one moment will make a difference, but we need to check it, yeah. So let's once again power it up with a CMOS battery in place this time. Yeah, 2D. I'll probably come back around again and stick on that. Yeah, and I heard the little click noise. Okay, so yeah, it's made no difference. Well, let's have a look under the microscope. So you can see here, I mentioned before on the first part of the video, there's a whole load of capacitors down by the slot, yeah. And if you look at them, they're in pairs, and each one, effectively, these pair of wires, tracks going this way, is a PCIe lane, yeah. And you'll see you've got 1, 2, 3, 4, yeah, 5, 6, 7, 8, okay, 9. You know where this is going, don't you? 10, 11, 12, 13, 14 mounted sideways, 15, 16, yeah. So there's a pair of these on each PCIe lane, and these lanes then they all come this way and they disappear under here, yeah, under the heatsink here. So this chip is controlling the connection, if you like, to PCIe, and this is probably where the problem is now. We can also, the same way, if we come over to the RAM, yeah, so this is the RAM slots, and you'll notice that the connections to the RAM slots on this all basically go up underneath the CPU socket, yeah. So the CPU looks like it has an integrated memory controller talking to the RAM, and then this chip, PCH, Northbridge, whatever you want to call it, is effectively communicating up here, yeah, and doing other things, no doubt. So what we can do is just check. I mean, it might be possible we've got like a broken connections under here, under the chip, yeah. So like, you know, the BGA isn't effectively connecting to one or more of these lanes, and that may well cause this sort of problem. Easiest way to test that is just to check the resistance from. You'll find one end of these resistors will read the resistance, the other end won't effectively. So I'll just connect my meter to ground, and we'll just go to resistor, yeah, just try on this one, yeah, 53 kilo ohms. The other end probably will just go open, yeah. I'm not exactly sure how these wired. I need to look at the circuit diagram really, but these are reading 53, and because there's nothing in the slot, I'm kind of assuming that this resistance I can see is coming from the BGA. So if I go down all of these resistors, and maybe if I see one that isn't reading 53k, that might just give me some indication that we're on the right track here, yeah. I mean, there's just some slight differences in 51, 54, but I doubt that is a problem, yeah. In fact, they seem to follow a pattern, don't they? 51, 54. I've gone off the picture. 53, 50. Yeah, 1. Yeah, let's just move a bit further in, so we're back under here. Yeah. So we can just check all these. I wasn't quite sure how far I'd got to off the picture. Yeah. That one. Somewhere here, I think. But yeah, these all look to be good. Yeah, I haven't so far found any thing that would suggest that there's like a broken BGA ball on one of these tracks. If they all read the same, they're probably all okay. Yeah. I was thinking if I see some difference here, it might be worth just reflowing this some flux under. I might do it anyway, actually. But it would be nice to see. We can say, oh yeah, look. Yeah, and then we've learnt something. These are sideways, so I'm guessing one end of this resistor. Yeah, 55 slightly different, but not that much different. Yeah, there's the other ones, other sideways one. Yeah, then there's just one more after that. Okay, so I think there's an ant on the motherboard as well. Yeah, it might. Yeah, you just see it go past. Yeah. When you live on a subtropical island, especially one that's only 2 degrees above the tropics, yeah, it's not like too difficult to see insects occasionally. Kind of goes with the territory, yeah. Oh, so okay, so they all read basically the same, yeah. But as best I can diagnose this, I think we have a problem with the chip under here. Let's get this heatsink off and let's just see. I'd imagine it's an AMD chipset. It's an AMD processor. Okay, so the heatsink's off. The first thing I notice is that the thermal compound on this is absolutely dry. I can't even rub it off with a bit of a kitchen roll, so that's not a good sign to start with. That would suggest that this thing has probably been running a bit on the warm side, shall we say. We can try a bit of isopropyl and just see if we can clean this off. Yeah, of isopropyl on the thing and see if it wants to come off now. It is coming off, but not readily. Yeah, a little bit of pressure. I'm sure we can get this off here, and we can have a look to see what this chip is. Okay. A little bit of scraping. Let's clean it up, and I'll be with you in a moment. Okay, I've cleaned that off as best I can. We can see the part number now, NF570-SLI-N-82, yeah. First thing that strikes me is some of these capacitors here don't look too clever. That one. Another one here. Looks like it's destroyed practically. Another one here, yeah. Those three capacitors look extremely suspect to me. Let's have a quick look at. Let's have another look. I need to get down the microscope. Let me see. Let's see what we can see with these things. What's going on here? So it looks like some sort of like heavy corrosion on there. Find something, just scrape at it with a little bit. Yeah. If in doubt, scrape at it. That seems to be a good idea. Let's have a look at that. Almost like something liquid's got under this. But I'm not sure that's the case, because it's only effectively got uncertain components of this one here, but not these, yeah. And if you look up here in this corner, we have much the same sort of problem, yeah. Perhaps this is a bit harsh to scrape it with, but oh, yeah. I'm not really sure what that stuff is, yeah. So look how these read on a test meter. Just out of interest, yeah. Okay, got a test meter there. I'll just read across them first. I'm not sure this is going to help us to fix it, but I'm just interested. Hope you are as well. So that reads like quite a high. Oh, very high, 6 meg. Is this one reading basically the same? I wonder if these were on the same voltage rail. No, that does. Oh, very high again. And the third one was down here somewhere. Yeah, I think it was that one. I've basically cleaned it off. Yeah. This is difficult. I'm not looking down the microscope. I'm interested to see if these things are actually connected together on the same voltage rail. So let's go there to there. No, that end isn't. And you'd assume one end of this is probably connecting to ground anyway, but not obviously not that end. So you go to ground, and then on the other. Yeah, so one end goes to ground. That's not unexpected. Okay, so we've got some crap on there, but I'm not convinced that's causing the problem. But we can try it, yeah. This chip, this board's like 2005 or 2007, and this comes from an era which is quite jokingly known as bump gate. Yeah, this chip. If it was off the camera, bump gate. So what went wrong with these is some sort of like substrate they put on here to stick these down, like due to heating and cooling, and it caused effectively to crack underneath. So this effectively, this is your silicon die, would lose connections to the actual substrate, this green area, yeah. And this is where your bad connections would form, rather than the connection between the substrate and the PCB. And I'm pretty sure that this is of that era. We know when this board was basically made. So let's have a quick look on the internet. I'm pretty sure you'll find bump gate, as it's jokingly called, is from the same time. Okay, let's go see what Google tells us about that. Yeah, so bump gate. It's a scandal, you see. That's where the name comes from. Yeah. Okay, so bump gate is it was generally called. Bump gate NVIDIA. That'll probably give us what you want to know. Oh, tell us about bump gate here. Yeah, NVIDIA bump. That's on bad caps. Bump gate, the destroyer of the GeForce 7000 series. Blah de blah. So this actually tell us. Yeah, this. It's okay. So the lawsuits were going on around 2007, 2008. Yeah, and that's exactly the time when this was made, or a year or two before, yeah, give the chips a chance to fail. Look, it's affected mostly 2006 to 2008, and we know this motherboard is of that era, yeah. So that's another clue. So it would seem to me we've probably got a bump gate motherboard here, yeah. And by the way, somebody in the comments also mentioned this. I wouldn't say they were one step ahead of me. They mentioned it first, but after I did the first part, I thought, well, if that doesn't fix the problem, there's no problems down by these capacitors. It's going to be this, yeah. So I think this is actually one of these instances where it's actually worth heating this up to see if it makes a difference, yeah. I'm not a fan of just warming things up, but I think we've got enough evidence in this case to say that we should warm this up and see if at least temporarily it fixes a problem or changes a symptom, so we can see we're definitely on the right track, even if we can't fix it, yeah. But just before I do that, because I've scraped all that gunk off, I'm just going to test this again. Okay, so it's all connected back up. We've got the post analyzer card in, the graphics card in. This is a thermal pad. I took this off a scrap TV actually, off the main board, and this is just like a small heatsink, but if I rest that on there, it at least gives this some amount of cooling, yeah. So I'm not sure just how fast that would get hot. I mean, it's not going to be on for very long, but if we do that, you know, it's not a bad thing to do, yeah. So that's just balance on there. It's not shorting against anything. Okay, so let's power this up and let's see what it wants to do now. Yeah, it went click. Same thing. Same thing. It goes click. So let's see. Yeah, it's a bit warm. It's generating a bit of warmth. Let's then try the now the technique of heating this up. Yeah, I don't think there's anything we can lose here, and I think we've got enough evidence to suggest that that may help. So let's try it. So first of all, I'll just heat it up. I won't try to reflow it. I'll, you know, get it hot enough to melt the solder. I'll just effectively get it hot. Yeah. So take the CMOS battery out, take these various leads out, and let's get the hot air and let's see if it makes any difference. Okay, I've just connected the thermocouple. You can see, by the way, that's the ambient temperature in my workshop office. I've been in here since about 30 minutes now, since I switched the air conditioning on. Yeah. So that's an idea. It gets quite warm here. Okay, so set to 450 on maximum airflow, and I want to try and concentrate. I'm just warm the area a little bit first, yeah. Take the CMOS battery out because it's close to this, but I want to try and get some heat once I've warmed it up onto the centre of this chip, yeah. Because if it says bump gate, that's where the problem is effectively, yeah. Just some of the thermocouple saying, yeah, I've just taken the heat away just so we can see what the thermocouple says the temperature is. What's the temperature on the top of that? About 125. Okay, it's a bit more than that. What do we have now? About 160. A little bit more. I think that should do. So we got it well towards 200, I'm guessing. Cooling down now. We're still over 100, yeah. So let's let that cool down and then let's see if that's made any difference to our problem. Okay, so it's all back together again. Let's see if the heating technique worked on this one. Yeah, power on there. Oop, just slightly dodgy power switch I have. Oh, we'll be needing the bleeper and the start button. Yeah, that'd help. Do you think that'd help? Yeah, power switch. Okay. So, what's it do? Well, it now doesn't do anything. Nope. That appears to have killed it. The standby labs, I know I got power coming in. Yep, that appears to have killed this quite dead. Let's make sure everything's plugged in, yeah. Nothing stupid that's in there. Okay. No. No longer even starts. Okay, so I think that's well, it kind of proved, I think, to some extent the problem was here, or at least by heating that up, it didn't help. Yeah, so there's one of these myths busted. It doesn't always work. Okay, okay, guys, I think that's really the end of that. Just checking everything's good. Yeah, power's on. In fact, I know power's on because the green LED is lighting up. Yeah. Well, have to be sure, like, you know, nothing stupid like the wires fell off. Yeah. Yep. Dead as a dodo. Okay, so all is not lost. I mean, we still have that very nice brushed aluminium case, which I'll probably use myself. We have the processor, which I've put onto the test board. So this is our test board now. This is the spare processing, see, it's got the grubby marks on it. Yeah. So I'm just going to use this board now. Let's just see whether the graphics card was any good that came with this, and let's just look at the memory as well, and then we can determine, you know, what we actually did get out of this. Maybe enough at least to get money back from it, yeah, and a nice case for free. Okay, so this is ready to go. I'll just put one of our test graphics cards in here now. Yeah, and that's booting. And we have a picture on the screen. Well, it'll probably come in and just say, please insert boot drive. Yeah, there you go. I did get the BIOS screen first, so that's okay. So let me have a quick look, go through this memory. Let's see if any of it was actually faulty. Okay, so I've just checked all the Kingston RAM, because that's what came with this machine. Yeah. I think it's that one or the one that's in the machine that came with it. Looks like the labels that were on the RAM that I arrived with. It's all the rest of the RAM is my stuff, which is stuff that I know is good anyway. Yeah, and there's one more Kingston here. Let's just check that one. Check that one out. So it looks like all the RAM was fine. Yeah, it was just that motherboard was obviously extremely flaky. Yeah, one bleep. And we have a picture. Okay, so we know the RAM that came out of it is good. Yeah. Let's have a quick look. So this is one of my test graphics cards. I know the other test card has previously been tested as good anyway, and both those two behave the same. Yeah. This is the one that came with it, the HD 5570. So let's see if this actually works now. Okay, that's in there. Let's give that a go. This one to behave differently. It doesn't seem to like that one. I think we're very unlucky here to have a faulty graphics card and a faulty motherboard. Yeah, it's obviously not happy with that at all. Oh no, I tell you what, it's booted up, and we have a picture. Yeah, we have a picture. Just for some reason took longer to boot. Okay, so I think there's a good chance that graphics card is actually okay. So what do we get? We got a couple of I think there were 2 meg strips. Yeah, no, that's a 1. I'm not sure exactly which ones came out of the machine now. Yeah, and there were the ones that were that kind of label on them. I think there were probably 1s. Yeah, there were 1s. Yes, we've got a couple of 1 gig strips of RAM out of it. We've got the HD 5570 out of it. Not the one. 5570. So that was about £20. Yeah, the RAM. I'll just keep it here. And the last thing we got was the CPU and then the case. Yeah. So let's have a quick look to see if this CPU is probably worth more than £2. Yeah. The number off the CPU, which is this one. Yeah. ADA, that number. Yeah. Which is an Athlon X2. It's a 4200 plus. So that's what it actually is. Yeah. That one. So let's have a quick look on eBay. I should imagine these things are, you know, 2 for £1. I don't imagine they've any value, but let's have a look. See what it says. Yeah, that's the one. No, I was wrong. Yeah, I was wrong. It's like about £8. Okay, so between that and the graphics card, we've got about £30, 25 to £30 worth of stuff here. Considering I paid in euros, yeah, a pound is about 1.2 euros. So that's profit, yeah. I mean, £30 is about 36 euros. Okay, even after eBay fees, then there should be a bit of a profit in that. Okay, yeah. So there we go, guys. That's the end of that one. Not a success, not a disaster. And let's face it, we've got that nice brushed aluminium gaming case, yeah, retro gaming case for nothing once this is sold. Okay, guys, that's the end of that. See you soon on the next video. Ciao for now.